OCR Maths and Stats Integration Techniques for C3 and C4. We'll start off by looking at this formula for integrating powers of x, and this is an AS Maths formula. The power cannot be equal to minus 1. That's one of the conditions. N cannot be minus 1. Starting with the first one, integrating x squared. So we get x, increase the power by 1, divide by the new power, plus c, the constant of integration. Yet you must add on the constant of integration, c. Moving on, integrating 4x cubed. So there's that 4 there, and then increasing the power by 1, dividing by the new power, and these 4's cancel, plus c. Integrating x to the power of minus 3, so we have x to the power of minus 2, because if you increase the power by 1, so minus 3 plus 1 gives you minus 2, dividing by the new power, plus c, or you can write this as minus x to the power of minus 2 over 2 plus c, or minus 1 over 2x squared plus c. Integrating something in third form, so let's change this to index form first, so integrating x to the power of a half, so increasing the power by 1, so that gives x to the power of 3 over 2, and then we're going to divide by this power, plus c, and dividing by a fraction is the same as multiplying by the reciprocal of this fraction. So if you flip this fraction over and then multiply by it instead, so instead of 3 over 2, if you multiply by 2 over 3, integrating a constant, so if we're integrating 5, you just multiply the 5 by x, plus c. Integrating a number of terms, make sure your terms are all inside brackets. So integrating the x, so at the moment that's x to the power of 1, so increasing the power by 1, so that becomes 2, and then divide by the new power, so that's the x integrated. E is just a constant, so like the previous example, we had 5 there, that became 5x. We've got e, so we just multiply by x. So we've got ex plus c. Just to point out that this is e times x, it's not e to the power of x. Integrating 1 over 4x squared is the same as integrating a quarter, and you can see the quarter here, and then the 1 over x squared is x to the power of minus 2. So that gives the quarter there times x to the power of, and we're going to increase the power by 1 there, and then we divide by the new power, plus c, and we can rewrite this as minus 1 over 4x plus c. In this example, we're going to use integration to work out the area of this shaded region that's bound between the curve y equals x squared and these two lines here, x equals 2 and x equals 4, and the x-axis. So we have the limits of integration, x equals 2 and x equals 4. So integrating first gives us x cubed over 3. Put the result in square brackets, put the limits on the outside, and then substitute the limits in, so putting the 4 in first. So we've got 4 cubed over 3 minus, and then substitute the 2 in, 2 cubed over 3, giving 56 over 3. In this example, we're looking for the area of the shaded region from x equals 1 to infinity. So rewriting using index form first, so integrating x to the power of minus 2. So that gives us x to the power of minus 1 over minus 1. And it would be more useful to write x to the power of minus 1 as 1 over x, like this. Because we're dividing by minus 1, we can put the minus in front, like this. And then when we substitute the limits in, so putting infinity into the denominator, so 1 divided by an infinitely large number will give us 0, minus, and then substituting 1 into here will give us minus 1 over 1, which is just minus 1, and that simplifies to 1. In this example, we're looking for the area that's bound between the curve and the y-axis. In the previous two examples, the area was bound between the curve and the x-axis, between the curve and the x-axis. So we had a function of x and then dx, a function of x and dx, but in this case we're going to have a function of y and then dy. So if we take the equation of the curve and rearrange it first to make x the subject, so x is equal to 16 minus y squared. This is our function of y. So we're going to integrate from minus 4 to plus 4 along the y-axis. 16 minus y squared, so there's the function of y, and because it's along the y-axis here, it's dy. So integrating gives 16y from the first term minus y cubed over 3, square brackets, and the limits. So substituting the limits in, so putting in the 4 first, here and here, and then substituting in the minus 4 here and here. Use appropriate brackets to avoid making mistakes with signs. So integrating to work out the area bound between the curve here and the y-axis involves having a function of y dy, and the limits here are along the y-axis, so that's y equals minus 4 and y equals 4.